Today I'm going with Baptiste to present you Bad Memory. It's a joint work with Dan Bonnet and Gustave at Stanford University. So it will be the last talk of the Blackhat, so we have something very special for all of you. We're going to show you a lot of cool attack. We have a very, very cool last part of the talk, so if you stay until the end, you will see very cool attack. Usually when I look at security mechanism, I found there is basically three main ways to break any security mechanism. So the first one is to find the design flaw. For instance, we all know that web is broken by design. You can also try to exploit any implementation vulnerability. For instance, Julien this morning showed 17 exploit on the kernel. And the third part, which will be the focus of this talk, is how you can try to make them irrelevant. So it might seems a little bit odd at the beginning, but bear with me for a second. So for a second, let's assume you get a nice house, like the one in the screen in Wonderland. And of course, you love your house, so you don't want anyone to get inside without your permission. To enforce this kind of security, what you're going to do is put a door, and this door is your security mechanism or protocol. And if a robber is smart enough, what he's going to do is not try to break through the door. He's going to try to find what we call side channel. And for instance, he might want to try to go through the windows, or he might want to try to go from the roof. And that's the basic idea we want to show you today, is how to attack very well-known protocol by not attacking them directly, but trying to exploit some side channel. More precisely, what we're going to demonstrate to you today is first how we can break into a WPA protected Wi-Fi network. Then we're going to discuss how you can attack HTTPS with cache injection. And in the third part, we're going to show you how we can steal private data from social websites and other sensitive information using what we call family attack. And finally, we're going to discuss a little bit smartphone and show you how we can actually attack them with something we call tab jacking, which is basically click jacking on steroid. So first, as a warm-up, let's start with WPA, protected Wi-Fi network. And so a long time ago, not a long time ago, people made a huge mistake, right? It was web. And web is broken, and everyone knows that here. And of course, we moved from web to WPA, which is still considered as a secure protocol. What didn't change during this transition is that the secret key, which is your WPA secret key, is still stored via a web interface. And it turns out that these web interfaces are vulnerable. So we look at a lot of brands, 8 of them, and we try to cover the most well-known brand. And we found that all of them are vulnerable. All of these routers have basically a web interface which are used to configure them and input your WPA settings, your IP address, and so forth. As a result, if you can attack this web interface, you will be able to attack the to break inside the WPA network. There is one limitation, though, is this web interface are only accessible from the inside network and not from outside, of course. So there is 2 ways to attack this. The first one has been shown this morning by Craig Hefner. You can do some DNS rebinding stuff. We're going to show you how to do it in another way, which is finding vulnerability into this web interface and into browser. So first, let's start with the basic. How are we going to get inside the local network? Our idea is you can probably do it by having a malicious page which would be executed inside the victim browser. This is not very difficult because many advertisement companies allow you to have advertisements which have JavaScript. And they do a poor job at enforcing which kind of JavaScript you are running. So if you pay, let's say, $100, you can probably get 100,000 victims to run your page. So it's really easy to scale up this kind of attack. It's not something really new. In the beginning of 2010, Avast released this report, and as you can see, there is a lot of companies which actually are serving malicious advertisements which are trying to exploit your browser. For instance, in this graph, you might not see it, but you have MySpace. And that's the basic premise of this attack is somehow the attacker is able to display you a malicious web page, and this web page will be used to attack your local network. Just a quick question. How many of you know what the same origin policy is? Please raise your hand. Okay, a couple of people don't. So just a quick reminder for that. So the same origin policy is the security mechanism which is used by any modern browser to protect one origin from another. You are browsing all the time multiple websites because you have multiple tabs or multiple windows, and what you want is protect one origin, let's say your bank, from evil.com as we have on the screen. So the basic idea behind same origin policies is very simple. Any origin can post data to another. Doesn't mean it can receive an answer. It just can send data, which allow interaction between web service. But at the same time, you are not permitted to read from one origin to another. So for instance, here, evil.com is not able to read data from Google, Gmail, for instance. So keep that in mind, please, during the attack, and I'm going to explain you where this can come into play and why it makes this attack a little bit difficult. So at the beginning, the attacker embeds his malicious JavaScript into a web page, and this web page goes inside the local network, and at that point, any firewall device are completely gone because you are inside the local network into the victim browser. So you're going to attack from inside, and you are basically having access to the web interface, right? And the first step would be to try to figure out which IP address the router has. What we are doing in our implementation is we try to scan for well-known addresses, the one we start with 1 and the one we start with 2, end with 1 and the one we end with 254. We do about 128 requests at the same time using XHR request, for those who want the technique behind this. And so the malicious page is going to scan until he found the right or the plausible IP address of the routers. Once this is done, then we have to decide if the router is using a web authentication, you know, the one like you have on Facebook or Twitter or Gmail, or if you use a very old mechanism which is called the basic authentication. It's an ugly pop-up where you have username and password and you can click OK or not. And at that point, that's one of the first hurdles in this kind of attack is the same origin policy prevent us to know what kind of authentication the router is using, because the web page the malicious code is executed into the advertisement origin, whereas the router has a different origin. So we can pass data to the router, but we can't actually read the answer. Fortunately for us, we were able to find a vulnerability in Firefox, which is currently reported and will be patched in the next version, which allow us to actually know by tricking the XHR request whether the router is using a basic authentication or a web authentication. At that point, the attacker still don't know what kind of router he has to attack, and the payload we have to attack router is really dependent on the brand and the model. So what we're going to do before trying to attack it is to fingerprint it. So the way you fingerprint a router, remember you can't read the data from it, so you can't read the brand and the model. You are doing two tricks. So the first one is well known, is you try to see if there is some well-known images inside the router which are accessible as public, like the brand logo. And the other one which we come up with is we try to see which open ports are available on the router. We are using this for a very good reason, is when you have HTTP authentication, actually if you request an image, you will get a pop-up, and the pop-up will trigger user suspicion. So you need to do first the port scan to narrow down your choice, and then if you think it's safe, try to fetch the image. And with this in mind, you should be able to get some positive results, some negative results, and we are able with our database to fingerprint really accurately which kind of brand and which kind of model the router is. When you have that, what you need to do is, of course, to authenticate to the router. So there is multiple ways to do that. First, a quick question. How many of you have a default password for their home router? Raise your hand. 1%? Everyone change your router default password? Really? Yes. Wow, that's impressive. Okay. Well, in this case, we can try the default password, and of course it might not succeed, specifically with a crowd like you, but we can still be able to brute force the password by using what we call a timing attack. Actually, you supply the password on the web login and you read the response. The basic idea behind timing attack is that if the page is only the login and password, it's a small page, so the time it will take to load is really quick. If you have all the interface with all the configuration panel, it will take longer. And this is very reliable on the local network because you are on the local network by definition. So we can use timing attack to actually differentiate. If you want to get an idea of the order of time, if you are in a login page, it's usually a couple of hundred of milliseconds. If you have a full page, it's usually 1 to 3 seconds. So it's really easy to tell apart whether you're logged in or you're not logged in. Of course, this only applies if you have a web-based authentication. If you have a basic authentication, this doesn't work, and we have currently no way to test that. Another limitation is since IE6 SP2, you can't actually authenticate to a basic authentication using Internet Explorer. So if you have a router with basic authentication, Internet Explorer can't be used to attack it. That's one of the limitations of this kind of attack. So we can brute force it, and we hopefully can get some of the router being able to compromise them. We also found, after trying to implement all of this, that certain routers have no authentication whatsoever. So they ask you for a login and password, but if you request directly the patch you want, it actually will happily give it to you. So the improper validation of the authentication, we did report that to the vendor. So we're going to authenticate to the router. And at that point, we're not shut down. Actually, the work just starts to begin because once again, the same origin policy kicked off, and we have to find a way to read the WPA key. We can't really read from one origin to another. Fortunately for us, or unfortunately, may I say, we found that 5 out of the 8 brands we looked at and the router we have XSS attack. So what we can do is we can inject them. We also found that no brand had any CSRF defense, so you are completely free to try to inject whatever you want. There is no CSRF token or any check on the referrer. And so we're able to inject whatever we want as soon as we can find an XSS. So if there is an XSS, what will happen is the malicious page will send a payload which will be used to load a external JavaScript which will be used to do further action like this. And what happened a lot of time, for instance, in this SMC example, is that we found an XSS which is not on the page where we have a WPA key. But this is not an issue because you have what we call cross-contamination problem, meaning that if you have one web page which is contaminated, what you can do is simply open an iframe, and the iframe by itself will open to the right page. So now we have an XSS which simply open an iframe, and we are able to read the content of this iframe because the XSS was already in the router origin. With this iframe, all we have to do is use a small piece of JavaScript and actually get the WPA key. At that point, the same origin policy became useless because, as I said, we can exfiltrate as many data as we want as the browser don't prevent us for posting data wherever we want. So one might ask, okay, sure, what happens if you don't find any XSS? If you don't have any XSS, you can't do this trick. What about all these routers? That's a legitimate concern. Well, what you can do is you can use a very recent attack demonstrated by Paul Stone in the Blackhat 2010 in Europe, which is called a drag and drop attack. So you can force the user, lure the user into drag and dropping, and it allows you to actually copy the data from one page from one origin to one origin. So it's more user intensive attack, and you have to do more like a fake game where you drag a small puppet back home or you feed a nice pony or whatever, but you can do it. It's technically possible, and actually we found out that every router we look at have no frame busting defense. So all routers are vulnerable to clickjacking. We don't make a demo, but you can also use that to reset any router you want and so forth. At that point you have the key, and the key go back to the hand of the attacker. And at that point you might say, well, fantastic, I have the key of one WPA network somewhere in the world. But if you have the key and you don't have the network, you can be stuck, right? So now the challenge you are facing is you got the key, you don't have the network. Well, there is an app for that. And I think Sami Kenvar showed it this morning as well. He found it, I think, almost at the same time as us. There is something really cool in Firefox, which is called the Locate Me protocol. So for those who ever seen it, no one. Okay, so for those who didn't see it, the Locate Me protocol is a protocol implemented by Firefox, which allows a web page to know where you are. It's basically meant to help a web page to display you more relevant information like which coffee shop are around or which shopping mall are around and so forth. And when you request it using JavaScript, what you get is this nice bar on the top. And if you click on share location, then Google will happily help Firefox know where you are. This is possible because behind the curtain, they are using the database which is collected by Google using the little car you see on the bottom of the screen. In Europe, this kind of collection of data made a lot of noise. I don't know if you see the headline on the press, but basically people in Europe was concerned about the idea of Google collecting that much Wi-Fi traffic. That's one of the bad usage that you can do with that. So what happened under the hood is the attacker will emulate this protocol and send the victim MAC address. I mean, if you have the WPA key, it's not as difficult to also get the MAC address. It's on the same page usually. So you take the MAC address, you send it to Google, and Google will happily give you back a longitude and latitude. We did try this on my own router, and actually it found my home pretty close, like 100 meters close to my home. And then you can also use the standard Google Map API. And with that, this longitude and latitude get a map. So you get a key and you get a map. How many of you want to see the tool in action? Everyone. Okay, great. So since we don't trust the god of the demo, we did make a video for you. So no live demo for you, but it was actually done on my own router at home before I changed it. So you see, first step we do the fingerprinting. Then we find the IP address of my routers. Then we have a fingerprinting step. We have the injection, and now we're waiting a couple of seconds because it's a reflected XSS, so we have to input it and wait until the router reboots. It's an old router, so it took like 20 seconds, almost done. And then you will see the WPA key pop up. Here you go, with my MAC address, and then we're going to use a geolocalization, and this is my location. And if you look closely where it is, it's really Palo Alto, and it's really close to where I live. So if you live close to me, well, you're free to buy me a free beer. I would be happy for that. So that's our first demo. In the second part, I want to discuss with you how we can attack HTTPS. We're using what we call cache injection. So a little bit of outline before that, because it might be a little bit confusing otherwise. First, we're going to give you a background how we build a web page. Then we're going to describe what a cache injection attack is. And then we're going to discuss how defenses are currently implemented to limit this kind of attack. And finally, we're going to show you how we find a way to actually bypass this kind of defense. So a web page, as most of you know, I guess, is compromised, has multiple elements. The first one is, of course, the HTML body, which contains a lot of links to a lot of elements like images and also JavaScript and possibly Flash. And all these elements can come from a lot of different origins. For instance, a lot of people are using Google Analytics, which track the usage of the web page, which is fetched from Google, and you can also fetch a map from Google. You can fetch recommendations for Yelp, so it's a huge mashup. And on the other hand, every browser, every modern browser, even smartphone browser, have a caching mechanism. So the idea behind the caching mechanism, which is used to improve the performance of the network, is when you request a web page, and this web page contains a JavaScript, which might be reused. The server might send you some header, say, this JavaScript won't change for a couple of hours, couple of days, couple of months. So can you please cache it locally and not ask me again until that amount of time? That's the basic idea. There is more subtle idea how to do that using e-tag and so forth, but that's the basic idea. And then, so next time the browser is going to request an HTML page which are using this JavaScript, instead of doing a request, you're doing it directly from the cache. So the net result is you decrease the network load and you actually display the page faster. So everyone has the incentive to use that. Actually, we look at how many websites on Alexa top 100,000 have at least one external JavaScript file which can be vulnerable to caching injection. And we found that at least 43% of these websites have one. Can you guess what is the most common used JavaScript library in the world? At least for HTTPS? Any guess? Google Analytics, yeah, good answer. Yeah, that's true. So the one we found in the mouse website is actually Google Analytics, which is followed by jQuery. And then you have SFW object. It's basically the library you are using for embedding Flash into the page. And the third one would be Google syndication, which is basically Google Ads. And after that, we have Prototype, which is another library, and Quanta, which is one other analytics. So let me describe now what the attack scenario might be. Assume that the user is very tired and wants to get a cup of coffee. He take his laptop and go to a coffee shop. Or for what it matters, he came to the Blackhat and decided to browse his email despite the huge warning you have on the page, right? Yeah, be careful. And at that point, he will browse sooner or later a HTML file, which is not encrypted. This file will be intercepted by the attacker, and the attacker will be able to inject in it a link to a script library, a JavaScript library, which will be over HTTPS. So there will be a warning at this point. We're going to discuss that in a few slides, but just bear with me for a second. And this is a malicious version of a cached library, let's say Google Analytics. And this library, if it's accepted by the user, will be in his cache, right? So the library is downloaded by the user, it's in the cache. And later, if the user go back home or go back to the office and feel more comfortable, he might try to, let's say, write a blog post to Blogger, or he might want to try to access, let's say, Twitter. And he fetch a page. The page contains a link to the JavaScript library. And at this point, instead of fetching the real page and the real JavaScript library, he will fetch the malicious JavaScript library from the cache. And there will be no warning whatsoever because you already accepted maybe 1 hour earlier, maybe 1 day earlier, or maybe 1 week earlier, depending on if you clear your cache or not. And at that point, this HTTP session is compromised. What makes this attack even more powerful, and I think that's the thing we really want to raise attention to, is if you are able to cache a malicious library like Google Analytics or jQuery, then you can compromise multiple websites with one injection. So if the user is clicking through one bad warning, then he's get all the websites who are using, let's say, Google Analytics, which is about 15,000 of them. Of course, there is defense against that. So that's a third part of this first section. And you have warning. The defense we have currently in the browser to defend against this kind of attack are SSL warning. This is the one from Firefox. It's a very intensive warning. You have to do 3 clicks to go through it. So you might wonder how to inject a malicious shared library. Well, first you can trust the user. I mean, to always trust the user to make the wrong decision. So they're very good at that. And they have good reason actually to do that. This is twitter.com over HTTPS, right? Do you know what happened when you go to www.twitter.com? Well, you get that. Why? Because they are using an EV cert, extended validation cert, and EV cert do not support wildcard. So if the user is trying to put www in front of every domain he wants to access, and that's what he has been trained for years, he gets this warning. If you want to have fun, you can also try to go to https://www.youtube.com, and you get a warning because that's a Gmail certificate. So certificate mismatch is really common. How many of you have ever clicked through this kind of warning? Come on, raise your hand. I mean, don't be shy. I mean, I did. I mean, everyone did at some point in their life. And actually, even this morning shows that, from Qualys, shows that you have actually 92% of SSL certificate which have a CNAME command mismatch. So it's something that, I mean, we try to put a negative warning to the user, and at the same time, almost 90% of the internet and even very, very well-known websites have a bad certificate, which means that we are giving the wrong message to people. So you might say, well, that's okay. We can also have positive warning, meaning we can give security indicator to people. Let me show you what Firefox did for Firefox 4. They did a nice study. This is a heat map of where people are clicking. So green one, which means no click, is a site identity which gives you information about the SSL certificate. No one is clicking on it. If you want to have the detail of the click, well, if you have an extended validation certificate, at most 1.4% of the users are clicking on it. So in the same time, users don't click on positive warning. So, well, this might not be a Blackhat talk if we're just giving fact and say, well, trust the user. It would be more fun if we find a way to actually trick the user, trick the browser into not displaying the warning. So that's what we're going to show you, right? More fun, right? And more interesting. So this is the IET warning, right? Who is using Internet Explorer in the room? No one. That's amazing. Every time I ask a question, no one raises his hand. That's okay. So this is a standard one, and it's a pretty scary one. They have 2 red shield and say it's not recommended, and they try to filter out the user. And let me show you what actually is happening when we're able to trick the browser. Here you go. So we're going to read a page which has a cache injection. You see the bar on the top? That's your warning, and that's the only warning you're going to get. And the only thing you can do is display block content. That's all. You can't do anything else. It's blocked. And when you click on it, we just inject you 5 different libraries at once. You might not trust us, so we're going to go to Blogger, and you have the HTTPS certificate, which is perfect, no warning. And we have a malicious version of jQuery in this page. So we're going to type my user and my password, not my real one, and when you click, you're being hacked. But actually, we did inject a lot of them. So if you go to Twitter, and even if you don't accept mixed content, so you're going to see a warning when we're going to click on Twitter. That is not because of the attack, that's because Twitter on the top left has images which are not over HTTPS, and we're going to refuse this image. So we're not going to display any content which is not over HTTPS. And you have only full HTTPS here. You're going to enter your login and password. And remember, it's already too late. The malicious JavaScript, in this case Google Analytics, is already in cache, and you get your session compromised. And this will not get away until you clear your cache, because we put that until 2:30. So we're not going to tell you exactly how we did mess up with the UI, because Microsoft asked us to give them time to fix it. We're going to release more detail on this, but that's really easy actually. And we found a ton of this kind of inconsistency. This one is also from IE8. As you see, it's not the same warning. So if you train your user, do not click into the specific shim, while you can also have some different behavior which might confuse even someone who are savvy. We tried to show this attack to someone earlier this week, and actually they get fooled by it. So that's one way. So let's discuss it a bit Firefox. So Firefox has this warning, right? I showed it to you earlier. And it turns out that Firefox did a very, very good job at being very consistent with this warning, and we were not able to remove it. So not being able to remove it doesn't mean we can't do anything. So we had to become a little bit more creative for that. And we come up with a nice solution. How many of you are familiar with clickjacking? Not everyone. Okay, so just one slide to make sure everyone is on page. Clickjacking works like this. The user sees a page, let's say a game, or download this movie, download this file, click here to accept this agreement, and she's going to click. What happened under the hood is you have a semi-transparent div in front of that, and you are basically aligning the 2 buttons. So when the user is going to click, instead of clicking to start or download, he's going to do something he will regret later. Here, for instance, leaving Twitter. Of course, Twitter is not vulnerable to clickjacking attack anymore, but it's to give you an example. So when you click, basically you do something you don't want. That's clickjacking, and that's something which is not enough discussed, as many people already try to raise awareness about. So, well, applying this idea to warning actually works. We're not able to remove the SSL warning, but we're able to actually clickjack it. So we're not completely able to clickjack it. We're going to show you this in a second, but we were able to remove 2 out of 3 clicks, and it makes the warning kind of confusing. So let us show you that. So basically, you're going to accept the agreement, which is the first click, and then you're going to click to download the game, and that's the only pop-up you see for the SSL warning for Firefox. You confirm the exception, and at that point, the JavaScript library is cached, and you're dead until you clear your cache. So same demonstration, still jQuery, malicious version of jQuery, which is cached. And as in the previous demo, you are able to steal information over HTTPS with not a single warning on the SSL version. Okay, so that was the 2 first part. I'm going to give you Baptiste for the 3rd part. He will going to show you one more attack, and they are all yours.
Okay, thanks. So in the 3rd part of this presentation, let me show you how we can steal private data from users using framing attacks. Framing attacks is an evolution of clickjacking and scrolling attack. Clickjacking, just presented previously by Eli, is a term coined by Jeremiah Grossman and Robert Hansen in 2008. And the scoring attack is a new attack just showed by Paul Stone in the Blackhat Europe this year. The scoring attack works as follows. In a first step, the targeted website is double framed. Here, in this example, you can see the mobile version of Yahoo Mail. In the second step, the attacker will use a browser feature called the anchor scrolling that make a page automatically scroll to a specific ID when adding it as a hashtag in the URL. Here, in this example, every email is associated to a specific ID. For example, the first one from Jocelyn is associated to the ID checkbox 29. So if I add this ID as an hashtag in the URL, automatically the page is going to scroll like this. Paul Stone showed that in the scrolling attack, you can actually read from the outside frame if the targeted website scrolled or not, breaking at this point the same origin policy, because you can actually know if in the framed website some ID are present or not. We use this idea to steal private data from users, making binary tests of specific IDs. In the following demo, let me show you how we can actually conduct an attack against the mobile version of Yahoo Mail. As you can see here, the victim inbox contains at least one email from me. So if I search for my email, the page returned will contain the checkbox 29 ID. However, if I search from a non-existing sender, the search will be empty, so the checkbox 29 ID will not present and the page will not scroll. We use this binary test to know if the victim inbox contains email from specific senders. As you can see here, we know that the victim didn't receive an email from Ellie, but received an email from me. This is a very serious security breach because it allows an attacker to know if a victim has an account on a specific bank or other drugs from a specific website. To prevent this kind of attacks called framing attacks, clickjacking and scrolling attack, most websites use frame busting defense. Frame busting is a defense that makes automatically a framed page come on the top of the page. However, Facebook have a slightly different approach to prevent clickjacking. When framed, Facebook displays a huge dark div on the top of the page, preventing the user from interacting with the Facebook content, but he is still able to see his information. When clicking on this dark div, automatically the page frame busts. This defense is useful against clickjacking. However, it will not prevent us from scrolling to specific IDs. We will use specific elements on different pages to know if, in the following demo, we'll show you how we can know using specific elements if the victim is logged on Facebook or not, who he is, and who are his friends. Actually, in the following demo, we use a non-existing ID. That makes we know if the user is logged or not. For example, looking for the registration ID, which only is displayed on the login page. On the left side of this demo is what the framing attack return, and on the right, what really happened under the hood. Here, you can see that we know that the user is logged on Facebook because the framed page didn't scroll. On the second point here, we are looking for a specific ID to know who is the victim. And as you can see, the page scrolls, so we know that this is not the good ID. This is not the logged user. But here, the page didn't scroll, so we know that Ellie is logged on Facebook. We use a third specific ID to know who is his friends. So here the page scrolls, so we know that this cute girl is not his friend. And for the last test here, you will see that the page will not scroll, showing that we are friends on Facebook. To prevent this attack, Facebook updated the profile yesterday, and now they are not displaying anymore any content, any information about the profile. They just show a little picture like this. For the last part of this talk, I will let Eli conclude.
Thanks. So for the last part of the talk, I'm going to, which is probably my favorite one, we're going to discuss tab jacking, which is clickjacking on steroids for our smartphone. As it has been said again and again, during the Blackhat, smartphone have a huge rise, a lot of Android phone around it, a lot of iPhone. How many of you have an Android or iPhone? Everyone. Ah, good. For this time, I have a lot of people raising their hand. And this has two main consequences, I guess. The first one is my iPhone is not working anymore because AT&T has not enough bandwidth. That's the first consequences. The second one is many popular websites has rolled out a version of the website, a mobile version, to be able to enable users who have smartphone to access it. And we found out that at least 53% of the 500 most visited websites have a mobile version. And you might not realize it, but the browser you have in this smartphone is fundamentally different from the browser you have on the desktop counterpart because of usability. The screen is so small that they had to make choices which are actually against security. The main thing you have, which is you don't have anymore you don't have anymore a Chrome which is there all the time. You know, the Chrome is a part of the browser on the top that we trust to put security indicator on the top of it, such as the URL bar or whether it's over SSL and whether the SSL is correct. We trust it's part of the browser to display information which are not spoofable by any attacker. On the other hand, on a smartphone, the attacker is able to have full control over the page and over the real estate because there is not enough rooms, which leave a lot of space to attack, a lot of attack surface to attack mobile phone. I think there is also other, behind the curtain, there is also a lot of behavior from the phone which makes things even harder for security perspective, like cookies. We know we have session cookies which die when you close your browser. Actually, on the smartphone, we found out that they are not. They are keep between one and the other. For instance, for the Android system, it makes sense because you have the notion of intent, which means that every program can be interrupted by another. So if you want to resume your browsing, you have to keep them. But for a security perspective, it's a nightmare because sessions tend to live longer on a mobile browser than on a regular desktop counterpart. Let me show you a demo to really illustrate this point. We were not the first one to find this out. It was actually, we found a paper which were mentioning exactly the same thing about 2 years ago, and no one actually paid attention to this paper. But we think it's a great paper, and I think you will find the demo very enlightening. So this is the wellsfargo.com mobile website, and in case you wonder, this is a real URL. It's the wf.com. You can go it on your smartphone. It will look like exactly like this. And does anyone knows if this is a fake page, or is it any danger on this one? You have the lock, HTTPS, everything is perfect. We don't mess up the demo. Do you think it's safe? Yes, no? No answer. Okay, well, it's not. Why? Any idea? Any idea why when you have the correct lock, when you have the 5 icon, when everything looks perfectly normal on the browser and we didn't crop anything, or we didn't do any pre-manipulation on this page, why is it compromised? It's not a real Chrome. You're right, exactly. And that's something people don't or might not realize is the URL you see on the top is just an image. Yeah, that's exactly what you see on, yeah, that's pretty scary, right? For those who didn't have hard time to picture it, you can do this, and actually you can use JavaScript to scroll. So basically the fake URL will appear, so I can actually spoof any website. We choose Wells Fargo, we could have choose Facebook, Twitter, Google, whatever you want. Because basically it's not a real page. And it's really, really scary. Once again, it's because we don't have the Chrome. You can't trust the Chrome. So we can't trust anything on a smartphone. And I feel this is very scary. I don't know if you think so, but that's the phishing problem with it. We try to move to this and try to see what we can do with this more. And we come up with the idea of tab jacking. So for those who wonder what tab jacking means, well, you take an iPhone or you take a smartphone, you add some click jacking, you shake it very, very hard, and you came up with this, tab jacking, which is basically click jacking on steroid. So there is one reason why click jacking is even worse on mobile phone is, first, as we will see, websites don't pay attention to mobile sites, and two, because of the usability feature. So this is a graph we made for a conference about 3 months ago, where we did a study on frame busting defense for website, normal website. And for this conference, we decided to do the same study for mobile website. Can you guess how many websites have a frame busting defense on their mobile site? No. No, you're pessimistic. 2. So yeah, we have 2, which is Facebook and Twitter, and it's because we went to this guy and asked them to actually do it. So that's, It was 0. Yeah, it was 1. I think Facebook had 1 in one of the websites and not on the other one, but yeah, it was close to 0. And actually, for us, it's really scary because it means that you have 2 teams. You have one team which are building the real website, which start to get a grip on what web security is, and they are doing a good job. And you might have a second team which is doing the mobile website and which has absolutely no idea what web security is, and they are doing all the mistakes we have seen in the website and we are fighting so hard to remove, resurfacing, and that's not a good sign. So to prove our point, we made the demo. How many of you are using Twitter? Okay, so for those who use Twitter, you might have noticed that in 2009 there were a huge worm, a clickjacking worm. I don't know if you remember this one, where actually you had link which said do not click here, and people were clicking. And when you were clicking on the link, what happened was they were adding more tweets which said do not click, and it became a huge worm and it almost crashed Twitter and did a lot of harm into the network. For those who don't remember, it was I think in May 2009. So we remade the same demo on the mobile website, and I'm going to show this one to you. So same thing, best game ever, and this time it's really easier for us to do click jacking because we can zoom on the button, so the tweet is like the entire screen, so no matter where you click, you're going to tweet. And if we go to Twitter once you're done, take us a little time because the emulator was slow. Here you go. So we were able to actually be able to inject tweets on the behalf of the user in their account. So that's click jacking on the phone. And it's actually more easy because we don't have to do all the nasty trick like having a CSS to have the button of the invisible div following your mouse. We can just use the zoom function. I have to mention that the Twitter team did a great job. They were very, very active, so they fixed it. So hopefully this one has been will not happen, but we know that there is a lot of other websites. We don't have frame busting defense on their mobile website, and we hope it will be fixed soon. We are a little early, but I think no one will complain if we finish earlier. We just want to tell you, recap a little bit. As odd as it seems at the beginning, you might now believe with us that you can actually attack a lot of protocol by using side channel attack. We show you how to extract the WPA key. We show you how we can attack HTTPS by cache injection, how to break into the same origin policy via framelink attack. We can actually search your inbox if you're using Yahoo, and how to use tab jacking and how scary actually smartphone browsers are right now. And if you like the video of the demo, well, we have a version on it on YouTube. We're going to make them public today. So if you want to rewatch it or want to share with your friend, we're happy to let you do that. And if you have any questions, we'll be happy to take them. Thanks. Yes?
Could you explain the details of the frame tapping or the frame when you were reading, checking for existence of IDs and then my frame?
Yeah, sure. So so the question was how the frame leak attack work in technical. So what happened is when you have two frames, one inside the other, one is the outside frame is controlled by the attacker, the inside frame is controlled by the is a website you want to attack. Portstone in the Blackhat 210 shows that you can actually do scrolling. So basically you can read if the scrolled property, so you can know whether you did scroll or not. So what we're doing is we are looking for a specific ID in a page. Like if you have a mail, you will have an ID because there is a mail in the page. And if this ID is present, we can test whether it's true or false. So we can do basically a yes/no search with that. Does it answer your question?
Actually, you can read the body on scroll of the outside frame. It's making when the page scroll, it move on in the outside frame. It will move, so you can know from the body properties if it moved or not.
Any other question? Okay, so thanks everyone for coming, and hope to see you at the DEF CON, I guess.